This video will cover a quick review on circles. Our first question is write an equation that shows the relationship between M and P. So as you could see from the picture, P is the measure in degrees of the central angle and M is the measure in degrees of the inscribed angle. If you forgot what those are, we'll review it right now quickly. Okay, so first of all, the measure of a central angle is equal to the measure of its intercepted arc. So what that means is that the measure of angle ADC is always going to be equal to the measure of the arc that it's intercepting. So that means that the measure of angle ADC will equal the measure of arc AC. Now the next relationship is that the measure of an inscribed angle is equal to half of the measure of its intercepted arc. Now if you forgot, an inscribed angle is an angle whose vertex is on the circle. So angle ABC is an inscribed angle because its vertex is on the actual circle. That angle, angle ABC, is going to equal half of the measure of its intercepted arc, arc AC. And we could write an equation for that relationship. The measure of angle ABC equals half of arc AC. So let's make an example here with some easy numbers so that it'll be easier to visualize what the relationship is between these two angles. Okay, so let's draw the circle again and let's add some easy numbers here. Let's say that the central angle is 100 degrees. How much would the measure of arc AC be? The measure of arc AC would be also 100 degrees. And what would be the measure of angle ABC? Angle ABC would measure 50 degrees. So if we had to write an equation to show the relationship between those two angles, there's two ways that we could do it. One way is we could write that 2 times 50 equals 100. Another way is we could write 50 equals 1/2 of 100. I'll repeat that. The first way we could write the equation is that 2 times 50 equals 100. And the second way we could write it is that 50 equals 1/2 of 100. Okay, so let's apply that to our question. Okay, so the two correct answers are we could either write 2m equals p, and we could also write m equals 1/2 of p. You have to understand both because one or both of them may show up on the exam. Question number 2. Angle DAF measures x degrees. What is the measure of arc DEF? Okay, so this applies to the question that we just did a moment ago. All right, it's the same relationship. Okay, it says angle DAF measures x degrees. So what is the measure of arc DEF? And the answer is the measure of arc DEF is 2x, because an inscribed angle is always half the measure of its intercepted arc. Okay, so that means that if you multiply it times 2, that'll give you the measure of the intercepted arc. For our next question, this is a relationship that you have to be familiar with, the circumscribed angle theorem. A circumscribed angle to a circle and its related central angle are supplementary. So in other words, if you look at that picture of the circle and those lines and the angles, okay, angle AXB and angle ACB are supplementary. That means that they add up to 180 degrees. You have to know that relationship. It's very simple to remember that. Whenever you see a diagram or a picture that looks like that, you got to remember that the central angle and the circumscribed angle together are supplementary. Okay, now we need that to know that relationship for our next question. Question number 3. Circle X is shown. Line BZ is tangent to circle X at point Z, and line BY is tangent to circle X at point Y, what is the measure in degrees of angle CBA? Angle CBA is in green. So we got to figure out what is the measure of angle CBA. Now, in case you forgot what tangent means, tangent is a line that only intersects the circle at exactly one point. So line BZ is tangent to the circle because it only intersects the circle at that one point, point Z. And line, and the other line, line BY, is tangent to the circle because it only intersects the circle at point Y. Okay, now let's get to answering this question. As we could see, angle ZXY measures 65 degrees. The first thing you have to realize is that angle ZXY and angle ZBY are supplementary because one is a central angle and its associated circumscribed angle. Okay, together they're supplementary. So that means that angle ZXY plus angle ZBY has to equal 180 degrees. Well, we already know the measure of angle ZXY. Angle ZXY is 65 degrees. So 65 degrees plus angle ZBY has to equal 180. So to figure out the measure of angle ZBY, let's subtract 65 degrees from both sides of our equation. So angle ZBY measures 115 degrees. Okay, now the next thing you have to realize is that angle ZBY and angle CBA are vertical angles because they're opposite from each other. Okay, and vertical angles are always the same. So if angle ZBY is 115, that means that angle CBA also has to be 115 degrees, and that gives us the answer to our question. So as you can see, just knowing that one relationship, that angle ZXY and angle ZBY are supplementary, if you know that, then that makes the problem extremely easy to solve. Question number 4 is also very simple. Are the two circles similar? Why or why not? Well, the first part of our answer is very straightforward. All circles are similar, no matter what. No exceptions. Okay, so if you ever see a question asking you if two circles are similar, automatically the answer is always yes, because all circles are similar. It's impossible for one circle to not be similar to another circle. All right, so all circles are similar. Now, if they're similar, that means that there has to exist a series of transformations that you could do to one circle to make it become the other circle. So let's just examine what the transformations are in this situation so that you could review how that works. Okay, so circle A can be dilated by a scale factor of 2 and then translated 10 units left and 12 units down to create circle B. Now, if that sounds complicated to you, let's look at the picture and I'll show you what that means. Okay, circle A, it has a radius of 2 units. Okay, you could draw either a horizontal line, a line to the right, a line to the left, or a line up and down, vertical lines, to find a radius. Okay, whichever way you do it, the radius is 2 in that circle. And when we go to circle B and do the same thing, you'll see that the radius is 4. That's how I know that the scale factor is 2, because if you multiply in circle A, if you multiply the radius of circle A by 2, you'll get the radius of circle B. So that tells us that it's being dilated by a scale factor of 2. And then in terms of moving it, if we look at the center, look at the coordinates of the center of circle A. Okay, if we take that center and move it to the left, we'll see that it's being translated 10 units to the left. And if you count how many units down, it's being translated 12 units down. All right, so it's a dilation by a scale factor of 2, and it's translated 10 units to the left and 12 units down to create circle B. And again, all circles are always similar, no exceptions. Question 5. What is the measure in degrees of arc BCD? Okay, and this is related to the first two questions that we did. Okay, so we're looking for the measure in degrees of arc BCD. Remember that an inscribed angle, That's an angle whose vertex is on the circle. An inscribed angle equals half the measure of its intercepted arc. So we're looking for the measure of arc BCD. Okay, so let's look at the angle, the inscribed angle that is intercepting that arc. That would be angle DAB, which is 94 degrees. So all we have to do is take those 94 degrees, and since we know that the measure of angle BAD equals half the measure of arc BCD, all we have to do is multiply 94 degrees by 2, and that'll give us our answer, which is the measure of arc BCD is 188 degrees. All we're doing is taking that 94 degrees and multiplying it by 2 to get our answer. Question 6. What is the difference in degrees between the measure of angle A and the measure of angle B? Okay, so as you can see, we have a bicycle with 2 wheels, and the measure of the angle of the spokes is different. Okay, so let's take the circle on the left first. Now remember that a circle always measures 360 degrees. Okay, so all we have to do is count how many angles are in that circle. Let's count how many angles are in that circle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means if we take 360 degrees and divide it by 10, that'll tell us that each one of those angles measures 36 degrees. So the measure of angle B is equal to 36 degrees. Now let's do the same thing with the other circle, with the other wheel. Okay, we have 1, 2, 3, 4, 5, 6 angles. So if we take 360 degrees and divide it by 6, we'll see that each angle measures 60 degrees. So the measure of angle A is 60 degrees. Now the question says, what is the difference in degrees between the measure of angle A and the measure of angle B? So we have to take those two angle measures and subtract them. So let's do that. 60 degrees minus 36 degrees equals 24 degrees. And that gives us our answer. The answer is 24 degrees. Okay, for our next questions, our next group of questions, you need to be familiar with the equation of a circle in standard form. This is not given to you on the exam, so you got to make sure to have this memorized. It's not as hard as it looks. The main thing to realize is that the center of a circle is h, comma, k. The coordinates of the center of the circle is h, comma, k. And the radius is r. Okay, so let's review this, and hopefully you'll remember because we did this a few weeks ago. Okay, question number 7 says the equation of a circle is x plus 4 to the second power plus y minus 6 to the second power equals 25. What are the coordinates of the center of the circle, and what is the radius? So you need to have this equation memorized. If you remember this equation, then all you got to do is look at the equation given to you in the question, see what's h and what's k and what's r, and that's it. If you see that, you don't have to do anything. So the center of the circle is -4, 6, and the radius of the circle is 5 because the square root of 25 is 5. Okay, so if you look at the answer and you look at the equation in the question, you could see the relationship. Okay, h has to be -4 and k has to be +6. One way to think about it is that you look at the number inside the parentheses and you put the same number in your answer with the opposite sign. So in the parentheses in the question it says +4, so your x coordinate for the center of the circle is -4. And it says -6, so your y coordinate for the center of the circle is +6. And for the radius, you just got to get the square root of the number all the way to the right, which is 25. The square root of 25 is 5. Okay, so I'm going to show another question just like this. See if you could answer it before I show you the answer. All right, so here's question number 8. The equation of a circle is x minus 8 to the second power plus y plus 3 to the second power equals 49. What are the coordinates of the center of the circle, and what is the radius? So again, we're going to need to know this equation. They're not going to give that to you on the test. And you got to realize how to find the center and how to find the radius. So if you know that, this is an extremely simple question. The answer is going to be that the center is positive 8, comma, negative 3. And the radius is 7 because the square root of 49 is 7. Okay, now for our next question, we're going to do the same type of problem, but it's going to be the hard version of these types of questions, okay, where you have to do something called completing the square, and you'll definitely see that on the exam. All right, so question number 9 says identify the center and the radius. So it's the same as the other questions. Okay, we have to find the center and we have to find the radius. The difference is that, look at the equation that they're giving us now. It's not written in the standard form of the equation of a circle. It's written the way you see it, okay? So there's a couple things that we're going to have to do in order to change it so that it'll be in the standard form of the equation of a circle. Okay, so for starters, okay, let's take the equation that they gave us and let's put the x's with the x's and the y's with the y's. Okay, because as you can see, if you look at the question, they gave it to us kind of scrambled. So I put x squared minus 6x together and y squared plus 8y together. Okay, now once we do that, then the next thing you have to do is make sure that you move any constants to the other side of the equation. A constant is a number by itself with no variable. So in that equation, 16 is the constant. I want to move it to the other side of the equation and get it by itself. So the way I'm going to do that is by subtracting both sides of the equation by 16. And that gives us our new equation. Okay, now the next step is I'm going to rewrite this same equation and I'm going to leave a gap. I'm going to leave a gap after the x to the first power. Or in other words, I'm going to leave a gap after negative 6x and a gap after 8y. Okay, and what I'm going to do, now I'm going to do the process that's called completing the square. So the first thing I'm going to do is I'm going to take the coefficients, the numbers that are in front of x and y, and I'm going to divide them by 2 and square them. I'll say it again. I'm going to divide them by 2 and square them. All right, so that means I'm going to get negative 6 and I'm going to divide it by 2. And whatever it gives me, I'm going to square it. That means to the second power. And same thing with the positive 8. I'm going to divide it by 2 and square it. When I do that, now I'm going to get, for negative 6 divided by 2 and then squared, I'm going to get positive 9. And for positive 8 divided by 2 squared, I'm going to get 16. And here comes a very important part that is very easy to forget. Even for me, I sometimes forget. Whatever you add to the left side of the equation, you have to make sure to add it to the right side of the equation. All right, so because I'm adding 9 and 16 to the left side of the equation, I got to make sure to add 9 and 16 to the right side of the equation. I'm telling you, that's the easiest part to forget in this whole process. If you forget that, you won't be able to, you'll get the wrong answer at the end. So that's very important. Okay, so now that I've done that, I have this equation, okay? And let's make some space here so that we can finish this problem. We're almost done. Okay, so there we have our equation. Okay, now what I'm going to do is I'm going to take this part right here and I'm going to factor it into a perfect square. If you forgot what that means, let me show you the answer to this part and it'll make more sense. I factored it into that. X minus 3 to the second power. What that means is that when I multiply x minus 3 times x minus 3, I'll get the expression listed above, x squared minus 6x plus 9. How did I get x minus 3? The way that I got it is because I need two numbers that when you multiply them together equal 9, but when you add them, they have to equal negative 6. Those numbers are negative 3 and negative 3. Negative 3 times negative 3 will give me positive 9, and negative 3 plus negative 3 will give me negative 6. Now I'm going to do the same thing with the other expression on the right. Y squared plus 8y plus 16. Okay? Try to answer it in your head before you see it on the screen. At the beginning, I'm going to put parentheses y, and then I need a number that when you multiply it times the same number will equal 16, but when you add it with the same number will equal positive 8. If you know your timetables, hopefully you're going to realize that that number would be positive 4, because 4 times 4 is 16, and 4 plus 4 is positive 8. Okay, now that we've done that, the whole purpose of doing that was because now, as you can see, we have our equation in the standard form of the equation of a circle. When it's in this form, we could easily identify what the center of the circle is and what the radius of the circle is. By now, you should already be identifying what that is just from looking at the screen. Okay, the center of the circle is going to be positive 3, negative 4, and the radius is 3. Okay, this is something I got from a previous review that we did for the chapter on circles. The answers are written in red. This is something that you should look at slowly before the exam, because it's almost for sure going to show up. Just to remind you what this is about. Basically, if you get a circle and break it up into the triangles as shown below, and take those triangles and create a parallelogram, which is what's shown below the circle. Okay, the height of that parallelogram is going to be the radius of the circle. It's written in red. Okay, the height of the parallelogram is the radius of the circle. And the base of that parallelogram, look at the base. The base is made up of the bottom edge of 4 triangles. The base is made up of the bottom edge of the 4 triangles. And then if you look back at the circle, 4 triangles, that's half of the circumference of the circle. That's half of the distance around the outside of the circle. All right, so you got to realize that the base of that parallelogram is half of the circumference of the circle. The circumference of a circle is 2 pi r. So if I get half of 2 pi r, the 2's cancel out, and the base would be pi r. I know that could sound like I'm speaking a foreign language, but this is something that we've looked at before when we were reviewing for an exam, and you should look at this slide carefully, slowly, before the exam, all right? It'll make sense. And you could also ask your teacher if you want a further explanation, because it's not that difficult. It's only difficult when you look at it the first time, but after you read it and think about it, it should make sense. Okay, let's move on to the next question. For the next question, these are 2 formulas you need to know. These 2 formulas are not given to you on the exam. You either have them memorized or you don't. As I've told my classes, it's actually easy to memorize these, okay? If you look at the 2 formulas, they both say m over 360. M stands for the number of degrees. Now, for the formula on the left for the area of a sector, the area of a sector is the shaded region. That's what we're talking about. You don't want to get the area of the whole circle, just the part that's shaded. So this is the formula for getting the area of the part that's shaded. All right, so you put the measure of that central angle, that's m, on top of 360, and you multiply it times. The right-hand side of that formula is the formula for the area of a circle, which you should already have memorized. So basically, the formula could be memorized as m over 360 times the area of a circle. Okay, now if you look at the formula on the right for arc length is the red line around that circle there. Okay, we're trying to measure how long is that red line in units of measurement, like inches, centimeters, meters, stuff like that. Okay, so the formula is m over 360 times 2 pi r is the formula for the circumference of a circle. So it makes sense because m over 360 times the circumference of a circle, the distance around the outside of a circle. That's the way you could memorize this easy, because in area of a sector, you're getting part of the area of a circle. And in arc length, you're getting part of the circumference of the circle. Hopefully that'll make sense when you look at the formulas. But the only way it'll make sense is if you already understand what the formula for the area of a circle is and what the formula for the circumference of a circle is. If you don't understand those 2 basic formulas, then you can't understand the bigger formula. All right, let's look at the question. All right, so here we have two questions. Question 11 says, what is the area of the sector? And question 12 says, what is the arc length of arc AC? All right, so let's do question 11 first. What is the area of the sector? And as you could see, we already have the formulas written there. But I just want to say once again, these formulas are not given to you on the exam. So if you don't know the formulas during the exam, you can't do the question. All you could do is guess. Okay, so for the area of a sector, area equals m over 360 times pi r squared. Well, if you look at your diagram, the measure of the central angle is 124 degrees. That's what m is. M is 124. And the radius is 5 inches, or 5. So let's substitute those two numbers into the formula, and we'll have 124 over 360 times pi times 5 to the second power. Okay, now you're going to work that out in your calculators, and when you do, you're going to get that the area of that sector is approximately 27.05 square inches. Or if they tell you to round to the nearest whole number, it would have been approximately 27 square inches. Okay, now let's calculate the arc length using that same diagram. Now in this diagram, they don't tell us the length of the intercepted arc AC, but we know what it is because if the central angle, if that central angle is 124 degrees, that means that the intercepted arc AC is also 124 degrees. Okay, we just did a bunch of problems about that. Okay, so that means that m is going to be 124, and again, the radius is 5. So we just enter that into our formula, and we're going to have that the arc length equals 124 over 360 times 2 pi r. So when you work that out in your calculator, you're going to get that the arc length is approximately 10.82 inches if you round it to the nearest hundredth. If it would have said to round to the nearest tenth, it would have been 10.8. And if it would have said to round it to the nearest whole number, it would have been 11 inches. Okay, and one last thing, which is very simple, which is whenever you have an inscribed quadrilateral in a circle, the opposite angles are supplementary. Okay, let me say that in a way that's easier to understand. Whenever you have a quadrilateral, a shape with 4 sides in a circle, and all the vertices are on the circle, that's what they mean by inscribed. All the vertices, all 4 of the vertices are on the circle. Then opposite angles are supplementary. So as you can see, they're color-coded. The angles are color-coded, and it says the relationship on the bottom. Angle A plus angle C has to equal 180, and angle B plus angle D has to equal 180. Okay, so the answer is already on the screen for this question because it's so easy, and I was in a hurry. I didn't have time to make it fancy. But basically, it says find the value of each variable. So for angle X, okay, angle X has to be supplementary with the angle opposite from it. So angle X and angle 105 have to be supplementary. So all you got to do is do 180 minus 105 to get angle X, which is 75 degrees. And angle Y is supplementary with the angle that's 120 degrees because they're opposite angles. So all you have to do is 180 minus 120 to find the measure of angle Y, which is 60 degrees. And here's one more example, same type of question. Question 14. Oh, I'm sorry, this is these are the exact same numbers. Okay, so never mind. So that's it for this review, guys. Make sure to study this before your exam. And I'll make sure to subscribe to my YouTube channel. I'm going to keep uploading reviews for your upcoming exam.